the psalmist said in Psalm 104 verse 24, "O Lord, how manifold are your works. In wisdom you have made them all. The earth is full of your possessions." Hello children! We're finally at the last period on our timeline, the last era, which is the Neozoic Era, meaning the age of new life. It is the shortest time on our timeline, but it's the most important because that is the time when modern man arrived. Neozoic means new life, and it shows that this was when the new and most complex forms of animals came into being. Now, just like the Cenozoic era, the Neozoic era has just one period, which is the Quaternary Period. And just like the Cenozoic era, this Quaternary Period has two epochs, the Pleistocene epoch and the Holocene epoch. So we'll be studying now the final part of the timeline of our development up until now. It started 3 million years ago, but we are still in the era of new life. Finally, we've come to the Neozoic era on our timeline chart. The Neozoic era, just like the Cenozoic era, had just one period, the Quaternary Period. The Quaternary Period was divided into two epochs, the Pleistocene epoch and the Holocene epoch. The Pleistocene epoch ended some 15,000 years ago and is generally known as the Ice Age period. But we should not think that for the entire duration of this epoch, frigid temperatures and ice prevailed. Major advancement of the ice cap both in the northern and southern hemispheres occurred in 4 stages. The spreading of ice was interrupted by warm interglacial periods, which were actually much longer than the glacial stages. Some scientists think that the Holocene epoch, the epoch in which we are now living in, is one of the interglacial stages, and that eventually another ice age will arrive. At the epoch of the Ice Age, glacial sheets blanketed as much as 30%, and in North America reached as far as south as what is now called St. Louis, Missouri. In Europe, the ice covered parts of southern France, the middle of Germany, and Poland. In the United States, the ice ages were named after places where outcrops of glacial deposits were most evident. From oldest to youngest, they were called Nebraska, Kansas, Illinois, and Wisconsin. In Europe, these same 4 glaciations are known as Gons, Middle, Reese, and Würm. The massive smooth volcanic cones formed during the Quaternary Period along the Cascade Range were worn and sharpened to their present angular shape by the erosion of massive glacial sheets. All throughout the northern part of the United States, we encountered a great number of lakes that had their origin glacial erosion. A huge ice age known as Lake Bonneville was created in the western part of the country. The Great Salt Lake in Utah is all that remains to remind us of this vast ancient body of water. Scientists discovered that a new larger lake, the largest of the Pleistocene epoch, covered extensive areas of Minnesota, North Dakota, and Manitoba. They named these giants of lakes Lake Agassiz. Glacial activities were also responsible for the formation of the Great Lakes. At the beginning of the Pleistocene epoch, cold wind blew over the vast plains of North America and Asia. The land was turning cold. Snowstorms and freezing rains forced animals to move south to water climates. Many European mammals such as the antelope, the rhinoceros, and the hippopotamus migrated to Africa, where they still live today. South American edentates and porcupines roamed northward across the isthmus of Panama in order to escape the advancing ice, while the mastodon elephants and furred ungulates were free to wander southwards. The once isolated marsupials and less advanced ungulates of South America were preyed upon by more cunning carnivores and eventually became extinct. The frozen Bering Strait often provided a natural bridge between North America and Eurasia. The horse, the bison, and many other mammals must have crossed it many times in both directions. The plant life of the Quaternary period was similar to what we have today. Tropical plants that once grew as far as continental North America gave way to hardier, more adaptable trees that could resist the advancing cold. During warm interglacial periods, fruit-bearing trees grew in great variety. Much as today, grasses cover the hills and plains. In the midst of advancing and receding ice, extremely climatic changes and drastic volcanic eruptions, nature seemed to be trying to bring about more adaptable forms of plant and animal life. At last, it is most highly developed form that emerged. At first, an ape that stood and walked like the man himself. The age of mammals that began with unimpressive little animals in the Tertiary period displayed its full potential in the Quaternary. Animals was their general increase in size, a promising sign of the shaping of more efficient and more adaptable species. The evolutionary process of mammals that led to today's familiar animals is typified by the developmental stages of the horse. The Pliohippus is the closest ancestor to our modern horse. Pliohippus appeared during the Pliocene epoch and developed widely at the beginning of the Quaternary Era. By that time, the horses had passed through many evolutionary changes. Its legs and feet were better adapted for running, and its teeth had become suitable for grinding grass. Pliohippus differed from the modern horse essentially in size only. It was the first one-toed horse. Related to the armadillo, Glyptodon here was an armored animal that had evolved from a small size of about 3 feet in the Miocene epoch to a much larger animal, increasing up to 12 feet in length during the Pliocene. Its name and name of all animals in this group come from two Greek words, glyptos meaning carved and don meaning tooth. Glyptodons means carved tooth. The unusual pig-like teeth were ideal for crunching spiders, centipedes, worms, and various insects. While Glyptodon's tails was well protected by plates and spikes, other Glyptodons could defend themselves even better with their massive spiked tails, which they could swing like clubs. With the abundance of plant-eating animals in the Quaternary period, carnivores had the widest selection of meat from which to choose and satisfy their voracious appetites. Rabbits and other rodents may have been the carnivores' main diet, but there is evidence that these animals preyed on larger creatures such as bisons, camels, and even horses, not sparing even the giant ground sloths like the Eunotherium that we learnt in the Cenozoic era. A good example is provided by Smilodon. Its dagger-like canines, combined with its powerful jaws, made this animal the most ferocious cat of the Quaternary period. It was larger than a modern-day lion that we have today, and Smilodon frequented the water holes where it ambushed and preyed upon unfortunate herbivores that came there to drink. A spectacular inhabitant of the Ice Age was the woolly mammoth. It roamed around the northern and central parts of Asia, Europe, and North America. Due to the frigid environment in which this mastodon lived, its remains have been preserved exceptionally well. Entire frozen bodies of woolly mammoths found in Alaska have yielded not just bones, but hair, skin, and even dried blood. This animal grew to a height of 99 to 100 feet at the shoulder. Its front legs were taller than its hind legs, and the animal's back descended rapidly. Much like our modern elephants, to which these beasts were related, woolly mammoths roamed the forest in herds. Their remains, as well as those of ancient bisons, giant deer, and woolly rhinoceroses, were often found buried in pits or near cliffs where these animals meet their deaths at the hand of prehistoric man. Man's pursuit and killing of these animals for food and clothing must certainly contributed to its extinction. The creatures we have studied up to now, some strange, others microscopic, and still others gigantic, have all told us same existing story of the development of life through the ages. But the most fascinating and surprising story is yet to be told. The emergence of man is an event that in itself marks a new era in the history of life on this planet. Primitive primates that emerged at the beginning of the Tertiary Period, more than 75 million years ago, are directly linked to some of the characteristics typical of man. Healthy, resembling modern man, the desert-dwelling prosimian developed a keen frontal vision, dexterity of the hands, social patterns, and intelligence surpassed only by later primates and man himself. The word primates, meaning first or highest animal, is appropriate because it stresses the high evolutionary status achieved by these animals. While monkeys and apes began to develop in the Oligocene epoch or mid-Tertiary, it was not until the closing of the Tertiary period some 10 million years ago that the first man-like apes emerged.
Ramapithecus
is an example of such primates, the advanced primates. However, much as it showed a direct linkage to man, it was still essentially an ape, holding a semi-erect posture some of the time and perhaps still running on four limbs when danger approached. Few fossils are available for scientists to draw final conclusions about this primate. Astonishing discoveries were made in East and South Africa in the 1900s. A variety of fossils indicated that more advanced man-like apes or hominids evolved about 4 million years ago. One in particular walked erect and had superior dexterity of the hand.
It was named Australopithecus.
There we have, meaning southern ape-like creature. The remains of this Australopithecus have been found only in warm regions, showing that its adaptability to cold climates like that of modern apes was poor. Its striking abilities included group hunting, using sticks and stones and tools as cave dwelling. Along with the remains of Australopithecus, scientists found some very primitive stone tools. At first, they thought Australopithecus had made and used them, but soon they discovered the remains of a primate that was a true man, Homo erectus, the first true man. The toolmaker descendant of Australopithecus lived around 22 million years ago. Homo erectus did not stay in the same place for long. Evidence showed that he roamed much more than many of his ancestors, and it is reasonable to believe that his adaptability to extremes of temperature is a unique characteristic if one compares Homo erectus with other primates that came before him. Homo erectus spread from Africa to Europe and Asia, producing a variety of descendants. During the last stage of the Pleistocene epoch, before the last glaciation of worm, a new kind of man developed differing from Homo erectus, essentially in intelligence, as measured by the size of the cranium or skull. That is, the cranium or skull. Scientists named this hominid Homo Sapiens, meaning wise man. Both prehistoric and modern man belong to this species. The story of the development of life is nearing the present, with Homo sapiens appearing on the stage of life some 500,000 years ago. The difference among humans began to be more cultural than biological. A group of prehistoric people discovered in the Neander Valley of Germany became known as Neanderthal man. Their tools and artifacts showed a degree of intelligence in all respects similar to modern man's. When the last ice age advanced, Neanderthal man suddenly disappeared and our own kind of human beings arose in Europe. The legacy of history and prehistory is to be found in Cro-Magnon. Here, this is the Cro-Magnon man, who is considered to be the first modern man. Crow paintings of 35,000 years ago found in Spain and southern France have shown him to be the first known artist. Cro-Magnon man spread throughout the world, and this kind not became really extinct. When his culture finally came to an end, it was soon replaced by a more progressive one. As the Holocene epoch began, about 15,000 years ago, Various human cultures had advanced to the thresholds of history. The civilization soon became established. The Neozoic Era, marked in deep red at the top of our timeline, ends with a jagged line to emphasize the story of life continues. Just like when we started in the Precambrian period with a jagged edge strip, here we have the Neozoic Era ending with a jagged edge strip to show that life goes on. And so, friends, we've come to the end of our study in the timeline of the development of life. You see, the Neozoic Era ended with a jagged strip. The red strip was jagged, showing that life goes on. Now scientists have done their work. Jesus is coming back, and that really will be the end of time. So keep studying, and thank you for studying this timeline of development of life with me.